Hi, this is Mel, and today we're gonna go through chapter 14 of circular functions. This is Math Method Unit 1 and 2 of VC subject. So this is all about circular functions like sine, cosine, tangent, and how do you find sine, cosine, and tangents through opposite side, adjacent side, hypotenuse, and how do you want to remember them? Like which one is positive in which quadrant. And some Pythagorean identity, which is very important, and a table you should memorize, and the graph, what does the graph look like? Yeah, so let's go through bit by bit. First of all, definition of a radian. So we have degree and radian. And these are two things we interchange. Like, we usually use radian because it's more simple and useful, but sometimes it's more easy for you to know which one is bigger or smaller in degree. So 1 radian, written as 1c, is the angle formed at the center of the unit circle. So unit circle means a circle with a radius of 1. By an arc of length 1. So the radian is defined by the arc. So the arc length, like the length of the arc. So if you cut the circle in half, for example, we cut over here, then the length of the circle is actually 2 pi. And if we divide it by half, so this curve over here should have length of pi. And we relate this with degree. So we have 360 degrees. So half circle, semicircle, we should have 180 degrees. So you can think of it like this. So for pi, it corresponds to 180 degrees. And that's how we interchange from radian with degree. So 1c is equal to 180 divided by pi, and 1 degree is equal to pi divided by 180. Okay, let's move on. So what about sine and cosine? We usually write it as sine theta cosine theta. So x coordinate p theta on a unit circle, we have x equal to cosine theta. So it's actually the x coordinate we have xy is actually equal to cos theta sine theta, where the theta is this angle over here. So numerically, the cos theta represents the x coordinate value, and sine theta represents the y coordinate value. For tangent, so tangent is defined as this. So tangent is equal to sine divided by cos. Or you can think of it as the gradient of this line, sine divided by cos, because it's y divided by x, and that's defined as gradient. So if the tangent to the unit circle at point A is drawn, then y coordinate of B is called the tangent theta. Okay, let's move on to circular functions and trigonometry ratios. So how do we calculate sine theta? Let's use this triangle over here. So if this angle is theta, How do we calculate sine theta by using the sides, the length of the sides of the triangle? So the sine theta actually equal to this side divided by the hypotenuse. So the hypotenuse, the h, is the longest side, the longest. And opposite side means opposite to the theta. And adjacent side means just right next to the theta. So sine is equal to opposite divided by hypotenuse, and cos is equal to adjacent divided by hypotenuse, and tangent is equal to the opposite divided by adjacent. So, or we can say, I talk about this, y divided by x, or sine over cos, which is from this definition. So this is definitely something you should remember, and some very typical is 3, 4, 5. Or you have, I think is 1 root 3 and 2. So this one is 60 degree and this is 30 degree. And you also have the 45, 45 triangle, which is 1, 1 root 2. These two are very important. You should memorize them. Yeah. And then let's move on to symmetry properties of circular functions. So we have 4 quadrants. It depends on which area are we in of the x, y coordinate system. So if we have x and y both positive, then we have, so all functions are positive, then we are in first quadrant, where the sine and cosine and the tangent not really tangent, we have the sine and the cosine are positive, and also tangent. So sine, cosine, and tangent are all positive, and in second quadrant we only have sine positive, so others are negative. And when in third quadrant, only the tangent is positive, so sine and cos are negative. And for fourth quadrant, we only have cos positive.